So in example 4, we are reminded never to divide both sides by a trig function. And we're going to start by looking at what not to do. So the original equation that's shown here in the notes is the tangent of x is equal to 2 sine of x. Okay, and the first thing that the student did in the workup here is they substituted in quotient identity for tangent, which is fine. So we would rewrite tangent as the sine of x divided by the cosine of x. And then in the next step, they multiplied both sides by cosine of x, and that would be the same thing that we would do here. So multiplying both sides by cosine of x, they cancel here, and sine of x is equal to 2 sine of x cosine of x. Okay, so far so good. Now, instead of following this path that's recommended up here, I'm going to show you what most students do in this problem. And this is just a disclaimer here. Do not do this, right? I'm starting by showing you what not to do. Okay, so here where students are tempted to go next is they see a sine of x on both sides of the equal sign, and so they try to do this. They try to divide out that sine of x from both sides, and they end up with 2 cosine of x on one side and 1 on the other side, and then they divide both sides by 2, and they have 1/2 is equal to the cosine of x. And to get the x by itself, they do an inverse of both sides, and so x would be the arc cosine, or cosine inverse, of positive 1/2. And then they would look at their unit circle and recall that positive 1/2 for cosine, let's see, that's the x-coordinate, that would be pi over 3. And then all students take calculus, so then we would know we need answers from quadrants 1 and 4, and so 5 pi over 3 would be the second solution. And then the student would go in their calculator, check those two answers, they would check, and then be shocked when their quiz would come back and they only got partial credit because they only found 2 of the 5 answers. And there are 5 answers to this equation, tangent of x equals 2 sine of x. So what we need to do instead of this path, this do not do, is we need to focus on where they went wrong. And right here was where that path went wrong, right? You cannot divide both sides of a trig function or a trig equation by a trig function. When you do that, you risk losing answers that do check to the equation. So instead of making that mistake, we're going to go this way, which is from here. We had sine of x equals 2 sine of x cosine of x. So instead of trying to divide out that trig function from both sides, we're going to set this equal to 0. So we're going to have sine of x, and then to move this 2 sine x cosine of x to the other side, since it's positive, we're going to subtract. So we'll have minus 2 sine x cosine of x, and now that's equal to 0. Now there's no force on this earth that is going to get us to put that equation in all the same trig function, right? There are no identities that we can pull out of our hat that are going to make this all sines or all cosines. We're just going to have to live with the fact that there's sines and cosines mixed together. And that's okay, because in this particular problem, there's a sine of x in each term of this binomial, which means we can go ahead and factor that out to the front like a GCF. So sine of x, if that's the greatest common factor, that's going to leave a 1 minus 2 cosine of x in the parentheses when we factor it to the front. And we can verify that by distributing to see how we get back to where we started. See, if we distribute sine of x times 1, we get sine of x. Sine of x times negative 2 cosine of x gets us back to that minus 2 sine x cosine x. So that's what it looks like to pull out a GCF to the front when you're doing it with a trig function. So next, now that it's completely factored, we can set each factor equal to 0 using the zero product property. So sine of x equals 0 would be the first equation we would want to solve, and then 1 minus 2 cosine of x equals 0 would be the second equation that we want to solve. So for sine of x equals 0, we need to do an inverse of both signs. So x is equal to the arc sine of 0. And when you look at your unit circle, the places where the sine is 0, remembering sine is the y-coordinate of the angle in radians. So the first place that has a y-coordinate of 0 would be 0. And then halfway around the circle at pi, we would also have a y-coordinate of 0. And then back again to the positive x-axis at 2 pi, we would have another y-coordinate of 0. So here are 3 answers that should satisfy that equation over the interval from 0 to 2 pi inclusive. Now for our other factor, we would subtract 1 from both sides, and we'd have negative 2 cosine of x equals negative 1. We'll divide both sides by negative 2, and cosine of x is equal to 1/2. Take the inverse of both sides, and x is the arc cosine of positive 1/2, which we already saw over here when we were doing it the wrong way, that gives us an answer of pi over 3 and 5 pi over 3, which, remember, we said over in the do not do this method, right? You do end up with answers that will check. You just lose some of your answers in the process. When we canceled out that sine of x from both sides in this first attempt, we lost 3 solutions from our equation. So this is the path that we want to take, which is setting things equal to 0 in your equation. Set everything equal to 0 and factor, and then set each factor equal to 0 to solve for x, as opposed to dividing out a trig function from both sides. So now that we have 5 possible solutions here to check, let's see if I can find a space to put this calculator. I guess I should rewrite my original equation over here so we can see it. Tangent of x equals 2 sine of x. That's our original equation that we want to check. So now I think I can get the whole calculator in the window here. So we'll turn it on, go to the mode, and make sure we're in radians. And now we're going to store 0 as the x and check that in our original equation. So tangent of x, and then second math opens the test menu, and number 1 here is the equals, and we want to check that that equals 2 sine of x. And anytime you put an equal sign there in your equation, you're asking the calculator to verify whether this is true or false. So if substituting 0 for the x's is going to make a true statement, the calculator will return a 1. If it makes a false statement, it doesn't check, the calculator will return a 0. And when we press enter, we get a 1. So we know that 0 checks. That is a valid solution. So next we're going to check pi. So we store pi as x, and instead of retyping that whole equation, we just arrow up to it and press enter, and the calculator retypes it for us. Enter again, and we see that pi also checks as a solution. Then we'll try 2 pi and store that as x. Grab that equation again, and 2 pi also works. Okay, then we'll check pi over 3. Store that as x. Grab that equation, and pi over 3 checks. And then last but not least, 5 pi over 3. We store that as x. Grab that equation one more time, and 5 pi over 3 checks as well. So you can see why it's the case that when students forget and they do attempt to divide out a trig function, they only end up with part of the credit for the problem because they only ended up with part of the answers. There should be 5 solutions that work, but canceling out that sine function, they only found 2 of them. So remember, do not do that, right? Instead, you want to do this, which is never divide both sides by a trig function, right? Always set it equal to 0 and factor instead.